Hi guys, welcome back. In this set of videos, we are going to talk about compound inequalities. To start, we're going to look at interval notation, which is how we are going to go about writing our solutions or how we are going to go about capturing what is on a number line. So the first place we want to start is kind of with our symbols with which we're comfortable. So a less than or a greater than means that we are including all values, but not the number next to the symbol, which we capture with an open circle on our number line, and that's going to relate to a soft parenthesis. Our less than or equal to means that it includes all numbers up to and including, or greater than or equal to means all numbers greater than or equal to all the way up to that one value. And we capture that on our number line with a shaded circle or a closed circle, and we use a hard bracket. The main thing that we're doing when we use interval notation is we're thinking about reading a number line from left to right. So here I have two examples. So the way I'm going to use these symbols to capture what I have here is I am going to look and I am going to write a succinct statement that tells me what values on here are included in the shaded region. So I look here and I see that -3 is not actually included, but it is a boundary. So it's a boundary, so it's going to be, I'm going to write that -3 as the boundary. But because it's not actually included, it's an open circle, I'm going to do a soft parenthesis. Now this means that -3 is the boundary, but not included. And you can see it's the leftmost region of my number line. So then I see that things are shaded. I'm going to represent that shading with a comma, and the shading goes all the way up to positive infinity. So I am going to write positive infinity. Now, positive infinity is not a number, it's an idea. So that means it can't actually be included. So I'm going to write that as positive infinity. For this next one, the leftmost number is negative infinity. Negative infinity is an idea, not a number. But I shade all the way up to 3, but in this case, 3 is included. So 3 is my boundary, so I write it. And it is included, so it gets a bracket. So that's a basic situation. Now let's look at a situation here where I have two endpoints. So I'm going to read my number line from left to right. So going from left to right, -3 is a boundary. It's a shaded circle, so it is included. So it gets a bracket. There's shading, so there's a comma, all the way up to 4, but not including 4. So it gets a parenthesis. Down here, I start reading from left to right. The leftmost value is negative infinity, which is an idea, not a number, so it gets a parenthesis. There's shading all the way up to -3, but not including -3, so it gets a parenthesis. The shading then starts again at 4. It's included because it's shaded, and it goes all the way up to positive infinity, which is an idea, so it gets a parenthesis. The last thing I need to think about here is how I am jumping over from -3 to 4. So we are going to write that as a U. So the U stands for union, and what it means is that we are jumping over a portion of the number line. These can get even more complicated, but we are just reading from left to right. So the leftmost value is -6. It's an open circle, so it's not included, so it gets a parenthesis. There's shading all the way up to -1, so it gets a hard bracket because it's shaded. We jump over a section, so there is a U. We have another boundary at 5, which is not included because it's an open circle, and we shade all the way up to positive infinity, which gets a soft bracket. So those are the interval notation. That's how we write things in interval notation. And from here on out, we're going to use interval notation when we write solutions to inequalities either compound or simple in one variable.